so this section is over functions. And a function is a relation that assigns each element in the domain to exactly one element in the range. So this is where we used to do like in Algebra 2 and Algebra 1, you would do like your charts and you would do your mapping. All we're going to do on functions is we're going to evaluate. Okay. So we're going to do 3 different ones. All of these are similar to what you're going to see in your homework. That's why I chose to do problems like this, where they have an A, B, C, or you might see an A, B, C, D, where they give you things to plug in. Okay, each part is a separate answer. So all of these are going to be functions that we're dealing with. Okay, so like on the first one, whatever's in parentheses is what you're plugging in for the variable. So this 2 is going to go in for x, and it's going to go in for every x that you see. So when I plug this in, this would be the absolute value of 2 over 2. Well, the absolute value of 2 is 2, and then 2 over 2 is 1. So you're going to reduce it as far as you can. There's no solving, it's evaluating, so you're just plugging it in and simplifying. So like when we get to like C, we're plugging in variables. You're never going to solve for this variable, you're plugging it in and just simplifying. Okay, so for B, we're plugging in -2. So this would be the absolute value of -2 over -2. Absolute value of -2 is 2, and 2 divided by -2 is -1. Okay, and for the last one, we're going to plug in x plus 1. So this would be the absolute value of x plus 1 over x plus 1. Okay, you can't solve for x. Now, simplifying. If you could simplify, you could. Now, these will not cancel because the one on top is an absolute value and the one on bottom is not. So this is actually your final answer. You can't simplify any further than that. Okay. So number 2 at the top. This should be a formula that you recognize, hopefully. I don't know how much of a volume that you did in geometry, but that is a formula that you use. Okay, so since this has pi in it, pi, I know pi is approximately 3.14, but we're not going to simplify pi. So if you have something in there that is already recognized, which we haven't talked about e's yet this year, you're going to leave the pi as pi. So when I plug in 3, this would be 4/3 pi times 3 to the 3rd. So we would go ahead and simplify 3 to the 3rd, which is 27. And then you're going to multiply. Now when you multiply, the pi is still going to stay as pi. So this would really be, when I simplify it, this would be, let's see, so that goes in, 3 goes in that 9 times. Sorry, that cancels out. This would just be 36 pi, because the 3 goes into the 27 9 times. Okay, if I plug in 3 over 2, so I'd have my 4/3 pi, 3 over 2 to the 3rd. So this would be 4/3 pi times, okay, so I'm taking it to the 3rd, so that means the top's going to go to the 3rd. So that'd be 27. 2 is going to go to the 3rd, which is 8. Okay, now I'm going to simplify. Well, 8 and 4, so 4 goes into 8 twice. 3 goes into 27 9 times. So this would simplify to be 9 pi over 2. Okay, and the last one, 2r. So this would be 4/3 pi times 2r to the 3rd. So when you take 2r to the 3rd, you're taking 2 to the 3rd and r to the 3rd. So that'd be 4/3 pi. 2 to the 3rd is 8. R to the 3rd is r to the 3rd. So when I multiply together, this would be 32 pi r to the 3rd over 3. And that'll be your final answer. Okay, we're going to do one more. And this one looks confusing. It's actually going to be your easiest one. Okay, there's three functions, but you only use the function that it fits in the category. So like if the number I'm plugging in is less than -1, I use this first function. If the number I'm plugging in is between -1 and 1, I use the second one. If the number I'm plugging in is greater than 1, I use the third one. So you don't use all three, you use the one based on the number you're plugging in. So like for this first one, I'm going to plug in -1/2. So I look to see where does -1/2 fall. Well, -1/2 would be between -1 and 1, so my answer to this is just 4. Since there's no x, you're not actually plugging that number in, that's just going to be your answer. If that was 4x, then we would plug in -1/2 in for the x. Okay, the second one, -2. So -2 is less than -1. So we're going to use this first function. So this would be 3 times -2 minus 1. So this would be -6 minus 1, which is -7. Okay, and the last one, 3. 3 is greater than 1, so we're going to use the x squared. So this would be 3 squared, which is 9. Okay, so this will be what the first part of your assignment looks like. Okay, so the next thing says find values of x such that f of x equals 0. So it's telling me that f of x is 0, so that means I'm going to plug in, I'm going to put in 0 where I see f of x. So this would be 0 equals 15 minus 3x. Okay, then we're just going to solve it. Solve it by factoring or solve a linear. So for this one, I would add 3x to both sides. So I have 3x equals 15. Then I would divide both sides by 3. So my answer would be x equals 5. Okay, on number 5, I put 0 in for f of x. So I have 0 equals x cubed minus x. Okay, this is a factoring one. So I can factor out an x, and I'm left with x squared minus 1. X squared minus 1 is a difference of squares. Factors into x plus 1, x minus 1. Then I take each part, and I set it equal to 0 and solve. So x equals 0 is already solved. I want to solve x plus 1. I subtract 1, so I have x equals -1. On x minus 1, I would add 1, so I have x equals 1. So since I have more than one answer, we're going to use solution sets. So I have 0, 1, and -1. So we've already solved problems like this year. It's just looking at the directions, that's what those directions mean. Okay, so this part, finding values of x such that f of x equals g of x. So since it says f of x equals g of x, what you're going to do is you're going to set f of x equal to g of x. So then I would have x squared plus 2x plus 1 equals 3x plus 3. Okay, so then I would just solve it. So I need to get everything on the same side. So I'm going to subtract 3x and I'm going to subtract 3. So I have x squared minus x minus 2 equals 0. This will factor, multiply to get negative 2, add to get negative 1 is negative 2 and positive 1. So it factors into x minus 2, x plus 1, and then I would solve each part. So x equals 2, x equals negative 1. Those two are your answers. Okay, if you can solve this one, same directions. You need to do it on a separate sheet of paper. If you can solve this too and give it to me by Monday, I'll give you some extra credit. Okay. So if you can solve that one, number 7, same directions as number 6, and get it to me by Monday, I'll give you a little bit extra credit. Okay, then the last thing you're going to talk about, or you're going to find, is you're going to have to find the domain again. Okay, so when you're finding domain, you'll have two areas where you could have issues. If you have fractions, you can't have a 0 in the denominator. And when you have square roots, you can't have the square root of anything that's negative. So like on number 8, I can find every single number would work, except for what's ever going to make this 0. So what you do is you just set that equal to 0 and solve. And that means my domain is all real numbers, except 0. Excuse me. Okay, number 9. What do I do when I have two fractions? Well, if you have two fractions, that means you have two exceptions. So this first one's easy, because that would just be equal to 0. X plus 2. If I set that equal to 0 and solve, I'm going to get negative 2. So if I'm finding the domain, this would be all real numbers, except 0 and negative 2. So both of those are not going to work. Alright, so this will be able to get you all the way through page 49, which is the rest of everything before your test. Reminder, this book work will be due on Monday, and you're going to have your test on Tuesday.